Assalamu alaikum dear students, I am your course instructor Nazir Yaqub with the subject of sports psychology. Welcome to this course. Today we will study objective methods of measuring human activity. They include heart rate monitor, core body temperature, doubly labeled water, pedometer or digital step counter, actigraph, accelerometer also known, and then multi-sensor monitors will be discussed. First of all, first of all we will study heart rate monitors. Assessed by heart rate monitor. Let's see how this heart rate monitor works actually.
Measure or calculate heart rate of a person. Nowadays, people use heart rate monitor when they go for gym, walking, jogging, or other exercise to keep track of their heartbeats. Generally, heart rate monitor device comes as a wearable assets like wristband through which one can easily identify heart rate per second. Wristband device has two inbuilt sensor, transmitter and receiver. As you can understand by name, transmitter emits green light and receiver detects reflected green lights. These two sensors should be in touch with human skin to get accurate result. As you can see in the image, green LED light is flashed several times in a second, which means it emits huge amount of green light which goes to our blood through skin. The receiver, which is also termed as a photodetector or light sensor, detects the reflected amount of light. Humans' red blood cell always reflect red light and absorb green lights. It is obvious that all green light will not be absorbed by blood cells. That means some of the light that is not absorbed is reflected back to the receiver. When your heart beats, blood flow is greater, resulting in increase of absorption of green light. For example, if you are jogging, your heartbeat will increase, due to which your blood flow will also increase, and hence it results in increased absorption of green light. While jogging, your blood flow is highest when your heart pumps and arteries expands, and is reduced between beats when arteries contract. By detecting fluctuation in amount of light being absorbed, the monitor can calculate how many times your heart beats each minute. So this is how heart rate monitor works.
After heart rate monitor, the second one हमारे पास जो option है वो है core body temperature. How we will measure the core body temperature. This is internal environment of the body measured by the T core. Let's see how T core works. Basically, these are the objective methods in which you can see how these devices can help us in measuring human activity, and they will display the our body's functioning in the numerical form.
Nowadays, the continuous monitoring of the body core temperature is an important measure for early detection of hypothermia. Previously, this was accomplished primarily with invasive procedures involving the esophagus or bladder, because only these procedures guarantee a high degree of accuracy. But now, Draeger has developed a body core temperature sensor applied to the forehead of the patient that delivers the same accuracy when measuring body core temperature as invasive procedures. How does this sensor work? The Draeger T-Core sensor consists of two separate temperature sensors separated by an insulating layer. This so-called double sensor is applied to the forehead of the patient. While one sensor measures the temperature near the surface of the skin, the other measures the flow of heat to the environment. With this information, the T-Core adapter calculates the body temperature close to the core and transmits the data to the patient monitor. The Draeger T-Core sensor is quick and easy to apply, and thus offers a good alternative to invasive core temperature measurement methods. For the continuous consistent core temperature monitoring in the OP area, the sensor can be applied already during the anesthesia introduction phase of the patient, and then may remain attached to the patient's forehead until after the operation, The T-core sensor thus actively contributes to preventing hypothermia in the patient during the entire OP process. Used in intensive care units, the T-core sensor continuously measures the temperature as an alternative to invasive measurement methods. The extremely light sensor cable increases wearing comfort for the patient as well. The Draeger T-core system combines the simple non-invasive application with the accuracy of an invasive procedure. It is easily integrated into the existing Draeger monitoring system. At the same time, documentation in the electronic patient file takes place automatically. Discover T-core now as a non-invasive alternative to previous invasive standard measurements of the core body temperature for children 5 years and older and adults. Ask your Draeger sales personnel for a demonstration of this innovative system. Please refer to
Okay, these were the methods that were used basically for the patients who are in ICU or where the minor movements are very important. Now, doubly labeled water is here. People drink water laced with stable isotopes of hydrogen and oxygen. The loss of these isotopes over time assessed. हम इसमें डबली लेबल वाटर में ऐसा वाटर जो है वो इनटेक करवाते हैं एथलीट्स को जिसके अंदर हाइड्रोजन के और ऑक्सीजन के आइसोटॉप्स होते हैं और आफ्टर दैट फिजिकल एक्टिविटी हम ये असेस करते हैं कि हमने कितने आइसोटॉप्स वाला वाटर जो है वो कंज्यूम करवाया था और आफ्टर द एक्टिविटी वो बॉडी के अंदर कितने आइसोटॉप्स जो है वो कंज्यूम कर चुका है और रिमेनिंग कितने जो है वो बॉडी से एक्सक्लूड कर रहा है। मेजर करने के लिए मेथड कौन सा यूज़ किया जाता है? असेसमेंट के लिए हम क्लाइंट का सैलिवा यूज़ करते हैं, उसके यूरिन का सैंपल ले सकते हैं या ब्लड का सैंपल ले सकते हैं। तो ये तीनों ऐसे मोड्स हैं जिनके थ्रू हम ये असेस करते हैं कि जो हमने ऑक्सीजन के आइसोटॉप्स वाला हाइड्रोजन के और ऑक्सीजन के आइसोटॉप्स वाला पानी कंज्यूम करवाया था क्लाइंट को, उसके अंदर से कितने परसेंट जो है वो कंजम्पशन हुई है। जितने ज़्यादा वो आइसोटॉप्स कंज्यूम हो गए होंगे उतनी ज़्यादा हाई एक्टिविटी होगी। It provides an estimate of energy expenditure considered a gold standard that is directly proportional to activity level. Basically इसमें हम एक बहुत ही हाई स्टैंडर्ड की फिजिकल एक्टिविटी की मेजर परफॉर्म कर रहे होते हैं कि जो हमारे पास रिजल्ट आ रहा होता है उससे हमें ये अंदाज़ा होता है कि जितनी फिजिकल एक्टिविटी हुई है वो हमें आइसोटॉप्स के थ्रू उसकी मेजरमेंट प्रोवाइड कर रहा होता है। नेक्स्ट हमारे पास ऑब्जेक्टिव मेजर के अंदर एक डिवाइस मौजूद है दैट इज पीडोमीटर। पीडोमीटर की हिस्ट्री अगर देखी जाए तो ये बहुत पुरानी है, बहुत अरसे से ये चल रहा है। वन ऑफ द अर्लीस्ट डॉक्यूमेंटेड फॉर्म्स ऑफ डायरेक्ट मेजरमेंट of athletic related behavior comes from लिनार्डो डिवेंसी 1452 से लेके 1519 तक जिनका एरा था, वहां से हमें इनकी हिस्ट्री मिलती है। He invented the pedometer during the midpoint of his life. गिब्स स्मिथ ने इसको जो है वो साइट किया है कि उन्होंने अपनी लाइफ के दौरान जो है वो इसे इन्वेंट किया था। लाइफ का ड्यूरेशन जो है 1519 पे ख़त्म हो जाता है उनका, यानी कि 1519 से पहले पहले की ये इन्वेंशन है। अब इसको हम जो नॉर्मल रूटीन के अंदर आजकल मोबाइल के अंदर एप्स आ रही हैं उसको पीडोमीटर के नाम से भी जाना जाता है, डिजिटल स्टेप काउंटर के नाम से भी जाना जाता है। वो भी वही फंक्शन करती हैं जो बेसिकली ये एक क्लासिक पीडोमीटर करता है। इसको हमने यूज कैसे करना है?
Intentionally designed a pedometer to be as simple as possible. Introducing Flash, a 3D pedometer and multifunctional clock combo. It's a fitness tracker that encourages you to leave behind your smartphone, allowing you to spend time for yourself and enjoy the exercise you love the most. Flash is the world's smallest 3D pedometer. The back clip and shoe buckle feature allows it to be stably attached anywhere on your body during exercise. The built-in 3D sensor and advanced modeling technology will measure and optimize your stride length in order to better calculate your calories burned and step counts. When you head out, just put Flash on and go. Once you're back home, Put flash on top of the multifunction clock, and thanks to the lightning pairing technology, all your fitness data will be synchronized wirelessly and automatically. The multifunctional clock also comes with some solid features. Its wide LCD screen is comprehensive, clear, and easy to read, and allows you to capture all information at a glance. Moreover, its digital calendar and alarm will help you better keep track of your daily performances. After years of research to find ourselves asking, how can we return to the essential functions of a pedometer with just a few simple tools, thoughtfully implemented, and making our device easy to use? Flash was created as a refreshing alternative to the tech monopolies. We want to convey a very simple idea. We believe that simplicity can bring us happiness and let us appreciate the beauty of life from a new perspective. Flash. Fitness has never been easier.
After pedometer, Actigraph is another device that is being used by physical activity performer and exercise fitness members. These are the small, lightweight, computerized accelerometer-based devices. They are worn typically at the waist, wrist, and or ankle. Mainly, these are two similar looking devices, but they have a little bit different functioning. In pedometer or digital step counter, you have only the number form of the physical activity, but in Actigraph you will see a graph of your physical activity that will ensure you easy understanding of your physical activity level, that it is declining or it's improving with the passage of time, and it has a record more than 1 day and some of the time 28 days. Actigraph usage, it rapidly and simultaneously digitize movement in 1, 2, or 3 dimensions. At the same time, 3 dimensions covered in Actigraph. Intensity of activity every 15, 30 or 60 seconds continuously 24 hours a day. आपकी फिजिकल एक्टिविटी की इंटेंसिटी क्या है उसको वो 3 मेजर्स में लेता है 15, 30 और 60 सेकेंड्स के हिसाब से और उसके बाद हमारे पास फॉर एज मैनी डेज एज मेमोरी अलाउज विच टिपिकली स्पेन 7 to 28 डेज इसके अंदर जितना भी आपका फिजिकल एक्टिविटी का रिकॉर्ड है वो 7 से लेकर 28 दिनों तक सेव रहता है आप कह सकते हैं 1 मंथ रिकॉर्ड आपका सेव रहता है आप इसमें देख सकते हैं कि लास्ट मंथ में आपकी फिजिकल एक्टिविटी कैसी थी और आप उसको प्रीवियस डेज के साथ कंपेयर करके मज़ीद बेहतर कर सकते हैं Now we will see how Actigraph works.
In order to initialize your device, unscrew the black knob on the side of the Actigraph monitor. This will reveal the USB port, which you will plug in to the computer. Once the activity monitor is plugged in and charging, it will have a green light that blinks. Once it is completely charged, the light will stay green. The activity monitors take approximately 3 hours to charge completely. After you plug in the Actigraph monitors, you will see that they appear in the main screen of the ActiLife software. Make sure that the arrow to the left of the device is checked for the monitors you wish to initialize. Note that the device must have at least 80% battery life in order to be initialized. Next, click the Initialize button and select the appropriate type of initialization. This will prompt a new window to open where you will select the desired data collection parameters, otherwise default parameters will be used. Here you will enter the dates and times when the device should start and stop collecting data. If no stop time is selected, data will be collected until the battery is depleted. This is also the screen where you can enable wireless if you plan to use Bluetooth capabilities, including a compatible heart rate monitor. Now, enter the subject name, information, and the wear position details into the grid. Select Initialize one device and a progress bar will indicate when initialization is complete. Once it is complete, unplug the monitor and replace the USB cap. When you're ready to give the monitor to a patient, you're going to want to set it up with one of the straps. There's a waist strap and a wrist strap option. For the wrist strap, Thread the small end of the strap into one of the wings on the monitor. Bring the strap all the way through, then thread the small end again into the other wing, just slightly, enough so that the patient can then slip it on their wrist and tighten the strap, fastening it with the Velcro. For the waist-worn strap, make sure that the strap is threaded through both the wings on the monitor so that it lies flat on the back of the monitor. Instruct the patient to put it on so that it is in line with their armpit and their knee. It should be clipped in the back and worn just like a belt. After the device has been worn for the desired amount of time, you are ready to download the data. Open the Actigraph software, then plug in the monitor. Verify that the box next to the device is checked and select Download from the menu. This will open a dialog box that will display the download options. Here you will want to select the file download location, name the file, and edit the user information. Once the download options are selected, click Download All Devices. When the download is complete, a Finish Downloading link will appear. The data has now been successfully downloaded and can be scored using the analysis tools in Actigraph. This concludes the tutorial on the setup, initialization, and downloading of the Actigraph monitors.
Comfortable where you are?
Yes, I am.
Do you have any pain in your chest at all?
No.
Okay, I'm just going to start by feeling on your chest to work out where to put these leads. Okay. So if you just relax your hands flat for me, just on the side. That's great, thank you. I'm just going to put some sticky pads on your wrist. And on your ankles as well. Okay, that's done. Thank you very much, James.
You have seen the procedure of ECG. Now we will see photoplethysmograph. What is it?
PPG uses light technology to measure heart rate through the finger. Beats per minute are thought to indicate emotional arousal and activation of the sympathetic nervous system. We typically see a rise in BPM in response to an emotionally intense stimulus. Also, as a function of attention, BPM fluctuates, usually dropping. Heart rate variability, HRV, is normally used as a measure of health, but increasingly, researchers are linking it to personality traits and emotional states. HRV is calculated by taking into account high-frequency and low-frequency component in the heart rate signal. The low-frequency band, 0.05 to 0.15 Hz, is related to acceleration of the heart rate during inhalation, and is thought to reflect combined activity of sympathetic and parasympathetic nervous systems. The high-frequency component, 0.15 to 0.5 Hz, is related to deceleration of the heart rate during exhalation, and is thought to reflect activity in the parasympathetic nervous system only. Theoretically, sedative stimuli should increase this high-frequency component, and in turn increase the high-frequency-low-frequency ratio, where a higher ratio would correspond to less stress. Please note that if you are interested in analyzing HRV, the length of each trial should be at least 1 minute if your measure is restricted to high frequency alone, or 2 minutes if you are using high frequency, low frequency, which is more conventional. In the Smart Lab, we calculate HRV using a spectral method in our Feature Finder software. For more exhaustive assessments of HRV, including temporal measures, we use the software Cubios HRV. When setting up the hardware to measure heart rate or heart rate variability, the settings should be as follows. The gain should be set to 100, and the LP should be set to 3 Hz. The first HP should be set to 0.5 Hz, and the second to 0.05 Hz. To set up Acknowledge to measure heart rate or heart rate variability, set the sampling rate to 125 Hz. The PPG sensor should attach to channel 4. Plug the red cord into the top outlet, the black cord into the middle outlet, and the blue cord into the bottom outlet. Wrap the electrode around the participant's middle finger. It should be snug, but not too tight, and be sure to ask if the participant is comfortable. Tell them to place their hand in a comfortable position and leave it that way for the experiment. They should not move their hand while HRV recordings are taken. The signal should move up and down at a steady pace. If it isn't, you can adjust LP from 3 to 10 and see if it fixes the signal. To clean the sensor, wipe it with an alcohol swab. If it isn't cleaned often enough, the signal will weaken.
We have a classical binocular cell which we have been asked to strain gauge for a customer who makes stiction equipment, fluid stiction equipment, and this acts as a very sensitive component in that stiction equipment. And what you can see here is we've cut the binocular cell, or the machinist has cut the binocular cell very thin to give a very sensitive binocular action when you load it from one end. The cell is held at one end and bolted into the unit itself, and then it's loaded on the other side, and you get compression occurring on the side closest to the section which is held, and tension far away from it, and you get that repeated again, of course, underneath, and that enables you then to make a full bridge arrangement to take account of that, so you'll get 4 times the actual sensitivity that is occurring on the surface. The gauges here that are used are...
They're one of our transducer class gauges, which is the N2A 06 SO71P 350.
So they're okay. So they're quite a small, neat linear gauge in actual fact. And as you can see here, we have a terminal strip in the middle where all the wires are brought from one side to the other and then connected as a single a component joint there to take away the actual cable itself into their instrument, which is, as I say, a stiction machine. But the coating on here looks like a very classical. What is it, Dave? Is it
It's MCOA again.
MCOA? Okay.
Yeah, and this unit is also temperature compensated.
Yeah.
आपने देखा कि ये जो क्लासिकल बिनोकुलर हमारे पास ट्रेन गॉज सेंसर है, इसकी हेल्प से हम ये कर सकते हैं कि जो फिजिकल एक्टिविटी है उसकी मेजरमेंट इलेक्ट्रिकल सिग्नल्स के थ्रू जो है वो एक वायर के थ्रू हमारे पास दूसरी डिवाइस के अंदर ट्रांसफॉर्म होती है। अब नेक्स्ट जो हमारे पास टाइप आती है दैट इज़ ब्लड प्रेशर सेंसर। ब्लड प्रेशर सेंसर जो है हमारे पास दो तरह से इस्तेमाल होते हैं, एक जो टिपिकल कफ बेस्ड है मेजरमेंट मेथड है, दूसरा कफ।
You just put your arm on the table, that's lovely. Fine. And I'm just going to feel your pulse now.
You have seen the cuff-based blood pressure measurement method. Now we will see cuffless blood pressure measurement method.
SomnoTouch NIBP by Somnomedics, a milestone in blood pressure measuring. Compared to current standard methods using cuffs, the SomnoTouch NIBP from Somnomedics makes non-reactive measuring possible even while patients are asleep, and it provides continuous beat-to-beat blood pressure values. SOT's patented algorithm determines the blood pressure via pulse transit time, PTT, measuring the time it takes for a pulse wave to travel from the heart to the patient's fingertip. It is recorded with an ECG and a finger clip. This patented method has been validated according to the International Protocol of the European Society of Hypertension. Measurement is completely non-reactive as it works without a cuff. Each inflation of the cuff disturbs the test subject's sleep and causes an arousal which can cause blood pressure to rise up to 35 millimeters of mercury. The measurement is continuous, beat to beat, and records all valley and peak values in the blood pressure curve. Nocturnal blood pressure spikes and fluctuations during REM sleep will be detected. This method minimizes the hydrostatic effect after changes of body position. It simultaneously records actigraphy values to help determine sleep-wake states and correlate blood pressure and physical activity during the day. For people suffering from insomnia, the correlation with the actual sleep time is especially important for the assessment of nocturnal blood pressure. The SomnoTouch NIBP is easy for doctors to set up and use. At the beginning of the measurement, a single calibration of the blood pressure is required. At the end of the measurement, data can be transferred easily via a docking station. A detailed report for the analysis can be created automatically. The advantages of the SomnoTouch NIBP become evident in the advanced report, providing all relevant blood pressure parameters for the entire time of recording. Blood pressure fluctuations after desaturations indicate respiratory disorders. Fluctuations due to cardiac dysfunctions can be identified in the ECG curve and the arrhythmia analysis. The actigraphy allows for a sleep-wake estimation in patients suffering from insomnia. The actual blood pressure behavior during sleep can be observed and false hypertension can be ruled out. The SOT NIBP provides 5 measurements in one: continuous long-term blood pressure, Holter ECG, oximetry, actigraphy, and pulse wave velocity as an indirect measure of arterial stiffness. Synchronous recording allows for a correlation of data, providing deeper insight into the nocturnal blood pressure behavior and making diagnoses more reliable. It also means less time spent on recordings, more options for reimbursement, and more efficient routines in your practice. The SOT NIBP, the all-in-one device for cardiology.
So now we're going to do the galvanic skin response. And the galvanic skin response is actually very useful for small fiber neuropathies. These are neuropathies that give you pain and burning in the feet. In fact, you can't even have the covers when you're lying down in bed cover your feet because it will trigger a burning sensation. Now, unfortunately, these are not easily detectable by routine nerve conduction studies, so we do the galvanic skin response to find out if the condition is due to a small fiber neuropathy. Now, the difference between these studies and the routine nerve conduction studies is we're going to use 2 channels. So we're going to put electrodes right here in channel 1 and also right here in channel 2. So in channel 2, I only need to put the black electrode, and also I need to put the red electrode. The green electrode is good enough for both sides at the same time. Here we go. So this is the setup that we use for the galvanic skin response. You see both channels are now connected. And because they're connected, now we have to put the electrodes from each channel in one place. So channel 1 electrodes will go on the hand, and channel 2 electrodes right here, and channel 2 electrodes are going to go on the foot. So channel 1 electrode, we're going to put the active electrode, the black electrode, on the back of the hand like so, and the reference electrode on the palm of the hand like so. And then we're going to put the ground electrode, which is the green, somewhere around here. So for the leg, for the foot that is, we're going to put only the black active electrode and the red reference electrode. And the black, again, is going to go over the back of the foot, like so. And the red electrode is going to go, again, there's no need to put the green electrode because we already have one green electrode in place. And so the red electrode, the reference electrode, I'm just going to put like this at the bottom of the foot. You can't see it, but it is at the bottom of the foot. So now in order to do the test, all I have to do is stimulate the median nerve. And by stimulating just the median nerve, we're going to get a response both from the hand up here and from the foot. The response is going to be slow because it's going to take some time to go up and come back. but it will appear. Here we go. And here I do not do this with raising gradually the stimulus intensity. I put the stimulus intensity at 40 right away, and I give her one shock, just one shock. And then theoretically, you're going to see some activities right here, and you're going to see two lines at the same time. That's coming from the hand, and it's coming from the foot. So basically, I'm going to put this like so, right there, like I stimulate usually for the median nerve. Make sure I have enough cream. Like I'm stimulating for the median nerve. Here we go. And I give her just one shock. So now I put the stimulator at 40 right away. In other words, I don't raise it gradually because I just want to give her one shock to see the reaction from both the hand and the foot at the same time. Relax here. Here we go. Just one shot. And we got the response. And the response is stored. And as you see, it's a huge response. So I'm going to decrease the sensitivity a little bit to see it better. I'll bring it down here. And that's the response from the hand, right there, the top one. Again, I need to decrease it a bit more. This here is the response from the foot, that red one there. And this here is the response from the hand. And as you can see here, the hand has a much better response than the foot because when you have a neuropathy, when you have an injured nerve or a diseased nerve, the hand is involved much later than the foot is, so the hand response is much greater than the foot response.
So after the galvanic skin response, we will see bioimpedance method, how it helps in measuring human activity. You will see this method is more important for the fitness workers and athletes, healthy athletes, those who want to maintain their weight or reduce their weight.
Notice that people around us are more and more concerned with a healthy lifestyle. But how can you tell whether a workout is actually delivering results? Stepping on a scale or checking the mirror provides some information. However, there is a far more conclusive method. A bioimpedance analysis, or BIA, can determine your body composition or determine the elements your body is made out of. This includes muscle mass, fat mass, and other parameters. This method can detect changes even if your weight remains the same after working out for a while. A stagnant weight could mean that while your fat mass decreased, your muscle mass increased. This type of analysis is also used in medicine to support diagnoses and therapies, as it provides valuable insights that go far beyond weight alone. During a bioimpedance analysis, a weak electrical current passes through the body to determine the body's muscle mass and fat content. But it doesn't do so directly. The BIA only measures the resistance of different tissues within the body. The respective resistance impedes the current of electricity differently. With the help of carefully validated formulas, the measured resistance allows for conclusions about the body composition. To make those formulas even more accurate, parameters like height and weight are also included in the calculation. You can already tell bioimpedance analysis does not measure the body components, but calculates them. The better the calculation formulas are, the more accurate the measurement results will be. To get exact BIA formulas, you compare the results of a measurement with a very accurate reference method. In validation studies for the Sika MBCA, for example, the BIA measurements of 125 individuals were compared to the results of a whole body MRI. The MRI is the most accurate method for determining skeletal muscle mass. The calculation formula for skeletal muscle mass was derived from the alignment of the body resistance measurements with the MRI data. Whether this formula delivered accurate results was tested on another 130 subjects and again compared to MRI screenings. The other body components each have a preeminent method of validation. As we saw, the best method for determining muscle mass is the whole body MRI. To determine fat mass, it's the so-called 4-compartment method. If the comparison method is inaccurate, the so validated device will also be inaccurate. Without verifiable validation studies, it's like stepping on a scale that only roughly determines your body weight. Rigorous validation studies are indicators of the accuracy and performance of Sika's BIA devices. Unlike other manufacturers, the measurements of the Sika MBCA have been validated in several studies against the most sophisticated reference methods. Those studies were published consistently and transparently in peer-reviewed journals. Therefore, there is no doubt about the accuracy of the results.
We have seen different methods of measuring human activity. We will conclude now. All the above mentioned methods were measuring basically these four areas. They were heart rate monitoring devices, or these were the temperature monitoring devices, or blood pressure measuring, and step counter or energy consumption measures. When we will choose मल्टी सेंसर मॉनिटर्स, उसके अंदर आप इसमें से कोई से 2 या 3 टाइप्स को ले सकते हैं. थोरली जितनी भी हमने डिवाइसेस को स्टडी किया है, अंडरस्टैंड किया है, all of them are making these 4 core areas. You can use human activity measurement from one area or 2 area devices. It depends on the requirement of your field, how you want to use them. At the end, I would like to get any kind of feedback or queries if you have any. Thank you. Thank you very much.